Hello, in this podcast we're going to learn how to create force diagrams to document the forces acting on an object. First we're going to learn how to label the forces, and then we're going to draw the force diagrams using vector force arrows. Let's get started. We need to have a way to identify forces, and we do that by creating labels. Here's the general template we're going to use. We're going to use a capital F, stands for force. Then as subscript we're going to have the type of force, comma, the object exerting the force, then an arrow, and the object that's receiving or feeling the force. Remember, a force is an interaction between two objects, and we must list both of the objects in the label as well as what type of force it is. So let's look at some examples. So in the previous slide we had the Earth's gravity pulling down on the cat, and that label would be F, gravity, because gravity is the type of force, Earth, because that's what's exerting the gravity force, the arrow, and the cat, because the cat is feeling the gravity force. The other force in that sketch was the rug pushing up on the cat, and that force starts with capital F. It's a normal force, and we'll talk more about that later. And the force exerting, and the object exerting the force is the rug, and the object receiving or feeling the force is the cat. Moving on to the skydiver picture, we had the Earth's gravity pulling the skydiver down, and that label would be F and subscript gravity, Earth exerting the force on the skydiver, and finally the air pushing up on the parachute. That's a force, it's a drag force, and it's the air pushing up on the parachute. So this is how we label our forces, and it's just a way of identifying them. Let's take a moment to briefly review the common forces that we learned in a previous podcast. I'll start out with the middle column. These are forces that act perpendicular to the surface: the normal force, buoyancy, and lift. Then in this column on the right-hand side, we have forces that act parallel to the surfaces: friction, traction, drag, and thrust. And finally we have some miscellaneous forces that can act in any direction, perpendicular, parallel, or any angle in between. And those are gravity, tension, and magnetic. And of course the magnetic and gravity are non-contact forces, which means the surfaces do not have to be in contact with each other. For all these other forces, the surfaces need to be physically touching each other. So let's move on and learn how to draw force diagrams. Force diagrams are a way to represent the forces acting on an object. In this case, we're going to draw a force diagram on the log, and it's best to start with an XY axis. That's what these dotted lines represent. So the first step is to identify the object and shrink it to a point. So we're doing the log, and we're going to shrink it to a point, and we're going to stick that dot at the origin. Next, we want to draw all the forces acting on the object, and to do this we're going to use arrows to represent the forces. The arrows are going to point in the direction the force is acting, and longer arrows mean stronger forces, and of course shorter arrows mean weaker forces. So we know there's a force pulling down towards the center of Earth. We also know that the ground is pushing up on the log. We can see from this picture that there's a force, the rope, pulling the log to the right, and we know that the ground is causing friction, hindering that motion, so it is pushing to the left. Next, we want to label all forces using our force label template. So capital F for force, the type of force, it's a gravity force, and it's Earth's gravity pulling the log towards the center of the Earth. Now let's look at this force. It's a normal force because it's two solid surfaces, the ground and the log, and the ground is pushing on the log. Next, this force acting to the right is a tension force because the rope is pulling the log, and tension is a pull force. Finally, we have the friction force because the ground is pushing parallel to the log and it's hindering the motion, so that makes it a friction force. Notice the ground is exerting two types of force. It's exerting a push force perpendicular to the ground, That's called the normal force, and it's exerting a push force parallel to the ground, and that's called a friction force. We do not want to draw forces that the object exerts on its surroundings. For instance, we know that the log is pushing down on the ground, but we don't want to show that force. We're only interested in the forces acting on the log. Similarly, we know that the log is pulling on the rope, but we're doing the force diagram on the log, so we're not showing that force that the log exerts on the rope. And finally, we want to use equality marks to identify pairs of balanced forces. Now let's look at these. First, horizontally, we know that these two forces are balanced because the log and the tractor are moving at a constant velocity. So we need to have balanced forces. If we look in the vertical direction, we know that vertically the log's not moving. It's moving horizontally, but it's not moving up and down. So we know that the gravity force and the normal force are balanced, so we need to use equality marks. So these slash marks or tick marks are called equality marks. Notice I used a double set for the vertical forces because while they're equal to each other, we don't know that they're equal to the horizontal forces. In fact, I'm pretty sure they aren't. So if we had just used single slash marks all around, we would be saying all four forces were equal to each other, and that's not the case. These two are equal to each other, so we use single slash marks, and these two are equal to each other, so we have to use a different unique set of equality marks, so we use double slashes. If we had a third pair of forces that were equal to each other, we would use triple slashes. Let's do one more example. This time it'll be for an ice skater. She is gliding along the ice. First, we need to shrink her to a dot and identify the forces acting on her. We have the Earth's gravity acting downward. We have the normal force of the ice pushing upward. And we have the friction force of the ice acting leftward. Next, we have to label the forces. We start with a capital F, and then in the subscript we give the name of the force, and after that we have the object exerting the force, an arrow, and the object receiving the force. The last thing we need to do is look for forces that are balancing each other and put slash marks on them. And in this case, we have the normal force and gravity force balancing each other. And we know that because the ice skater is not speeding down to the center of the Earth, nor is the ice skater speeding up into the air. Well, this ends our podcast. I hope it helped you understand how to draw force diagrams, and have a good day.